recording. So, this is the question that we are going to do today. As you can see, you've probably seen this question before, actually, just from another chapter. Actually, I'm pretty sure that you have. So, we have 3 links, as you guys can see. Well, okay, 4 links. Ground, this one, this, and that, right? So, what we're going to do is we're going to do the links broken apart thing. But what we're also going to do is you guys are going to type into the chat the rules, the 5 rules of dodgeball. Except what I mean is solving this question. So force analysis steps. So let's start at 1, as we should. Go ahead and type them in. What do we got here? What is the first step? I'm burning this into your head. It's not that I have memory problems. Break the links apart. I agree. Right? Step 2. Free body diagram. Free body diagrams. 3. What is the third step? Create equations. So start creating equations for each link. Got it. 4. Number the equations as you move along. And 5. Collect. I'm assuming it's collect the equation into the metrics. Yeah, so it's collect the equations into a matrix. There you go. So like I said, I'm not doing this for my health, I'm doing it for yours. So hopefully on the exam you'll remember that. Or you'll just pull me up on video as I talk about it on the exam, either one. So, force analysis steps. We have this. So let's start off doing the first one. So I'm going to very quickly do a free body diagram. I'm going to do them for each one. So link 1, you guys are going to have to use your imagination here. So link 1 is going to look like this. Right. Link 2. Let's go like that. Link 2. Trying to get them in their actual shapes here, or in their actual directions. And link 3. This oddly shaped ball. So these are all the links that we are doing. Link 2 is right here. So and link 3. Nope, not 4. 3. Okay, we're not doing a very good job here. And 4. Alright, so link 2, which is this one right here, link 3, this one, and link 4 is the big circle up there. So we're going to start with link 2 as usual. So the first step has been completed. We have broke apart the links, right? Or break apart each part of the mechanism. So check mark. We did it, guys. Now, free body diagram. That's the next part. So the free body diagram is where we have to then move and make our links and forces. So I'm going to use a brush for red. Red will be attachments to other links. And then this one attaches up here. Yeah, okay. So those are where the forces will be happening, right? And then 2D shapes, we're going to draw. Obviously, we'll make that a little thinner. Right? We'll do green. Green for forces. And those forces are labeled as, well, this is where you have to use your own head for a second and go, all right, so our link is connected with the ground, and the ground is 1, so this force down here is F12, but up here it is F23, right? Does everybody agree? F23 is right here. then F12 is right there. All right, and then we do this line in between, which I will change that color to the black there. So then you have R. So real quick, essentially how you do this one is that, so in the middle here, that is the center of gravity. The distance from the force acting, or the force being put on the link internally to the center of gravity is R of the same force. So if it's F12, it's R12, right? Or R23. And really, I don't know if I want to label these, but I guess I can. I'll just do one here. So R23, R12. Right? So R23 is the top one, R12 is the bottom one. First free body diagram. I'll just do the rest of them, you know, as fast as possible. If you have any questions, you guys can stop me though. So this is F24, negative F23 or F32, because we have already used it over here. So this one on the other link must be equal and opposite. So negative F32, and then R 23. R24. Alright. And then back over here, onto the next one, is that we have one force acting upon this part right here, which is F34, but negative F34. Right? So negative F34 is that force. And then there's one more force. Looks like it's going straight up in the air, so that is how I will do it. F41, yes. So I'm going to just kind of do it like that. Actually, we're going to do something different. I figure I use external forces to be a little bit different. I always like to use stuff like that. Alright, and then that one is F14, right? F14. And then, obviously, since the center of gravity is in the very center of the circle, the distances are B41s and R41s and etc., right? So, we have all the free body diagrams created with all the external forces and internal forces. We can now move to the second part, which I will go ahead and check Marcus as we move along. We want black, just for consistency and to not annoy me. All right, so now we have start creating equations for each link. So like I said, we start out making another text box over here, and we start picking equations from this. So link, let's try that again, and link to equations. So link to equations. Our total force equation will be F12 plus F23 equals MAG2, right? MAG2. Oh, I always do this, M2AG2, because it's the mass of 2, because the masses aren't the same for each link. So you have to specify. It's a known. So the mass of each link is obviously known because this is something that we would know if we put it together, right? Like if you bought the links for this, you would know how much they weigh. Obviously, if you made this mechanism, you would know how much you would weigh whenever you made the parts. So it's not, M2 is known. Let's put it that way. F12x plus F23x is equal to M2AG2x. And then F12y plus F23y is equal to m2ag2y, right? So everybody understands that this is the total forces at play. We have one here and one here. This is the x component, and this is the y component, so your sines and cosines type thing, right? Now we have to do the final one, which is the moment equation, which is involved in rotations. So our equation for moments is the following. It is r of x times f of y minus r of y times f of x. So what we do that is we plug this exact thing in, and we do r12x times f12y minus r12y times f12x. And then parenthesis this off. Although once again I forgot the q at the beginning, but that's okay. We can do that later. Plus r1223x times f23y minus r23y times f23x, and then plus q2, right? Because remember, we do have this force right here that's acting on this link. It is our input torque, and so q2 is part of the moment equation, right? So essentially, if you were to break this down, what we have here, I actually didn't put that down. Oh my dude, what is wrong with me? Why do I always do that? I'm still waiting for a bunch of does in the chat from like Simpsons. I do this every time. So while we do that, can someone explain to me why having the torque part of it makes sense for the moment? So like why do we have to include that? Anybody? No. So for that last equation, why do we have to have the moment part of it? So think back to your statics, right? So like so I know statics was a long time ago for a lot of people. It was for me as well, trust me. Both times. So I remember statics fairly well, and there's a part of that. So why do we have to include the moment, or why do we have to include this torque that we're putting in here into our final equation for our moment? It's not really a trick question. Because, well, we don't know if it causes bending per se, but it causes rotation, right? I think that's what you meant. Rotation. We don't know. It could, I guess. Yeah, okay, not what you meant. All right, fair enough. Yeah, you're an honest one, Jackson. R23y times f23x plus q2 is equal to I2 times alpha 2. All right. Jeez, man. I didn't, I'll explain afterwards, but yes, I did. But it was not due to, it wasn't here. It wasn't at Southern Illinois. But yes, the answer to that question is yes. So, link 3. So, link, yeah, and that, by the way, there's hope for all of you. Just letting you know. There's hope. So, I'll tell you other ones too. So, link 3, we have negative f23 plus f34, right, is equal to m3, almost did it again, ag3. And then we have the x component, which is minus f23x plus f34x is equal to m3ag3x. Minus, yeah, as you can tell, I'm getting a little tired of typing these things out. It is how it is, unfortunately. But I'm hoping that this is starting to soak in, that this is, this is what we do, right? It's total force, components, moment, right? I'm hoping. So minus R23x times F23y plus R23y times F23x. Okay, and remember I switched the signs because we had a negative force over here. So we have to switch the signs in comparison to our previous equation. Only for this first one though, the rest of them are the same, or the other side of it is. X, okay, yeah, is equal to I3 times alpha 3. Yeah, that looks good. So stop me if I stop making sense, by the way. Like if you don't understand what I'm doing or if there's a problem, please stop me because I might have made a mistake in there somewhere. I'm prone for one every now and again. Alright, actually, more than that, more than likely. Alright, so link 4. So link 4. So we have, so far we have one force, which is the link, basically it's pinned to the circle, right? It's pinned to the roller. And then we also have F14, which is right there, is the normal force of the ball, right? Of the circle. Alright, so once again we have to flip the sign, so it's F34 plus F14 is equal to M4 AG4 minus F34. So we have minus F34x plus F14x is equal to M4 AG4. And now you might be wondering, well, wait a minute. Why is there an x component on this force? Because it's acting upward right now, right? So the problem is that as you can see, I know so you broke apart the links to show the forces, but if you look at the surface that this thing is moving on, very clearly this thing will have an x component, right? As this thing is moving, it will not always be acting straight up and down as the picture is showing. And by the way, the picture, we don't even know if it's acting straight up and down, right? Like, could you imagine, like, you can't tell the difference whether or not this thing is 89 degrees or 90 degrees, right? The force acting. So the x component of this, obviously, as this ball moves around this surface, will increase or decrease, right? So there will be an x component, but that's why I'm writing it as such. I mean, some people might wonder, like, oh, well, why is there an x component there? Just figured I would, beat you to the punch there. But maybe you guys weren't going to say anything. All right. So those are x and y again in our total force diagram. So now we have something else. We have the moment equation, right? So moment equation, we have to do minus R34 times R34x times F34y plus R34y times F34x. Yeah, okay, that's right. Plus R41x times F41y minus R41y times F41x. And then this one is plus Q, I think it's minus actually. Is it minus Q4? Is that what it is? Yeah, it's so wait, that's written in. Oh no, it's still supposed to be plus. Never mind. Plus Q4 is equal to I4 times alpha 4. Right? Got it. Give me 1 second. So, is everybody good how we are so far? Is everybody... Oh, I already had it open. Look at that. Oh, how ready was I? Okay, good. I was right. Yeah, this solution isn't in the book, so I was making sure that this sign was correct. And it is. So... yes, so you can move Q2 the other side, you're right. So if you wanted to do this, you would just subtract this off and it'd be I2 minus, or I2 times alpha 2 minus Q2, you're right. But just in case, so real quick, you don't always solve for the input one. So I know that sounds really like dumb because you would imagine that the input is something you would know. But I know that some of the questions, not in my class, but in previous versions of this same class, they would give you the output and tell you to find the input, and so the equation changes. You would put Q2 here, remember, because we've actually talked about this. I showed you the difference between finding Q2 and Q4. All it is a simple rearranging of equations. You just put Q2 here, and then you do the same thing. Essentially, you do the same thing you do with Q2 with Q4, and then you solve for Q2 in the matrix. But that's it. It doesn't change much. So that's why I'm going to stick with the input-output thing. I don't want to flip that around. But yes, Q2 can be on the right side. So you would subtract this over and you'd have it over here. Correct. All right. So here is our blank space so far. The Taylor Swift song, right? Yeah, I think so. All right. So moving on. We have the last part, which is to do the matrix. Now, these haven't been good. My drawings of them have not been good. I will agree with that. But today, I'm feeling better about it. So we're going to go up here. We are not going to fill this in solid. Number equations. Thank you, Jackson. Or Muhammad. So, you are correct. I should have numbered the equations. So, I will do that now. So, we have number 1, 2, 3, 4, 5, and 6. And you have 7, 8, and 9. And then the unknowns, I will do down here. Knowns. We have R12X, R12Y, R23X, R23Y, R34X, R34Y, R41X, R41Y, and then we have Q4. So that is 3, 6, 9. So there are 9 unknowns, 9 equations. Look at that, guys. We did it. So there they are. Let me go ahead and prepare for the matrix part, which I know is going to be absolutely brutal. Maybe I should make this thing way bigger than it needs to be. I think that might be a smart choice. We're going to have a massive matrix just so my writing can finally fit in. No bounds could hold my writing back. Yeah, it's going to be like that. God, that looks good. All right, so we're going to... You think we need more time for this exam? You're probably right. I agree. You're probably right. But you haven't seen the exam yet. So it could be one question. It could be two really short ones. You don't know. So, but yes, you are probably right. I don't think the normal amount of time will be sufficient. I agree with you. So we'll talk about that probably at a different time. Let me turn the... I got Comic Sans in here. Anyway, so our first one is going to be f12x, f12y, f23x, f23y, f34x, f34y, f14x, f14y, and then q4. And then I know what you guys are going to say. Well, man, you really didn't use a whole lot of the space there. This is what we were getting at. This is going to be, yep, okay, so we're going to do that one. Does that sound better? I think it sounds better. See, looks good. Now over here, we're going to do the same thing. So we have to do that whole thing again, but only for the equal sign. So the first equation was m2 ag2x. Then it was m2 ag2y. And then it was I2 times alf2 minus q2, right? And then it was the same thing again, but for all the other ones, m3 ag3x, m3 ag3y, and then it was I3 times alf3. And then we do it again, which is m4 ag4x, m4 ag4y, and then it was, the last one was I4 times alf4. So that's 3, 3, and 3. Okay, cool. We are good there, and I'll try to line them up so they look nice. All right, so far so good. I think you guys would agree that this is the best matrix I've done so far. And it just happened to be the last one we do, so it's been pretty good. So now it's time to, this is the is this a calligraphy pen? Should I do that? I don't even know what that. All right, so now we have to fill in this part. So the tough part is I'm going to have to zoom out a bit because we have to see the equations because of how badly I did this. But that's okay. We'll get to it. So our first equation is f12x plus f23x, right? So we go down the list. Does our first equation have an f12x? The answer is yes. So we put a 1 there. Does it have an f23 or f12y? The answer is no. So you put a 0 there. Does it have an f23x? The answer is yes. So you put a 1 there. And then it has nothing else, so then you put 1, 2, 3, 4. How many do we have here? 6, 7, then 8, and then 9. Right? And then we move on to the next one, which is f12y and f23y. So this one, like I said, because it is the now y equation, it's the inverse of this one, essentially. So you can kind of fly right through this. Which is 5, yep. Does that make sense? Because it's now the y equation, you just put a 1 wherever there wasn't one before, right? I hope that makes sense. All right, cool. So now I move to the moment equation, which is, I think we're starting to get to a point where I can use this. So it's r12x, f12y minus r12y, f12x. So let's start with the first part. So is there an f12x in the equation? The answer is yes. So I'm actually going to use a text box here because I think that that'll probably be more helpful. So, is there an f12x? The answer is yes. It is a minus r21y attached to it. So that is our first one to use, R12y minus R12y, which is right here. I know it's really hard to see, but it's down here, F12x minus R12y. Then we move over. Is there an F12y? The answer is yes. It has an R12x attached to it, a positive R12x. Okay. And then we move on to the next one. Is there an F23y? The answer is yes. And it has an R23x attached to it. So we move over R23x. And then is there a F23y? Or an F23x. Where did I do that? Oh, this one should be a negative F23y. Sorry. Minus F23y. Or R23y. And then the next one is the same. It follows the pattern. So this is y, x, y, x. If people didn't see that one. And then from there, we then do a bunch of zeros again. So, because there is nothing left in the equation. There's a Q2, but that's not part of what we're looking for. So you just have 0, 0, 0, 0, and 0. Perfect. Now we do the next one, moving on, which is the length 3 equations, which is F23, F34. So is there an F12? The answer is no. Is there another F12? The answer is no, but there is an F23. So F23 is a minus 1, because remember we had to flip the sign. So minus 1 for this one, F23x. And then we had to do a 0. And then it's a positive F34x. And then you put zeros the rest of the way. Which is 4. Yep, okay, we're good. And then, like I said, the other one will be the inverse of that. So you put a 0, negative 1, 0, 1. Because it's the y equation, right? And you can you can actually do this one out, but it'll end up being just this again. All right, and then we move on to, once again, the hardest part, which is the moment equation, because there's a kind of a lot going on there. So let me do this. So in the first one, for the moment equation, do we have an an F23x? The answer is yes. F23x has a positive R23y, so R23y. And if you guys know that this is the pattern, you guys can pretty much just go to the next step. Essentially, the pattern is going to follow like this. Whatever the first one is, this one will be an x. But whatever if it is an x thing you're looking at, so if it's a force in the x direction, you will have a y attached to it. It'll be an R23y. And now we're looking at the y version, you will have an x attached to it. Right? And if the first one is positive, the second one's negative. If the first one's negative, the second one's positive, right? Hopefully that makes sense. And now this one will be the inverse. This one will be minus R34y. And this one will be let me see, let me make sure. Yeah, this one will be, because we're on F34x. And F34x is a minus R34y, and then the other one's an R34x. 34x. And the reason why this one's different is just because we had to change the sign in the middle. And that should be good. And then you draw the rest of them. So you have 5 zeros after that. Oh, wait a minute. Oh, I did it wrong. You're right. I just realized it. I should have put zeros in front. That was my fault. Because I have to put zeros for the front of these because there's nothing in the equation for those. So 1, 2, and then it starts that. So yeah, my fault there. I was waiting for... That was a test, guys. So let me do it again. My fault. So what did I say it was? R23y. And this is minus R23x, right? And then it was minus R34x, or minus R34y, and then it was R34x. Something to that effect. And then that makes 6 right there, so I just need 3 zeros. 1, 2, and 3. Yep. Alright, cool. Moving on to the next one. F34, so once again we had to flip the sign, so we move down. So this is none in there, none here, none here, and none here. But this is where we start the 3-4 category, right? So the 3-4 category, we have a -1 for an x, we have a 0 for a y, and we have a 1 for x, which is a positive, and then we have no 1 for y or q4. And then, like I said, you can pretty much fill the pattern out yourself. Oh man, that is a massive -1. Let's try that again. Fill the pattern out. And then we move on to the last one, which is the moment equation for the last one. So I will, this time, put in zeros. So we need zeros all the way up until 3-4, which is this one right here. Okay, so all the way till 3-4, and we have, for F34X, we have a positive R34Y. So let me get a text box out for this one. So R34Y, and then we have a negative R34X comes afterward, right? And then obviously if we continue the pattern, we have a minus R34Y, pretty sure, yep. And then we have a positive R41Y, R41X. And let me do that. And then one more 0 at the end. Oh, wait a minute. Nope, there is 1 there. I forgot about that. So if you remember our equation, there is a 1 for Q4. Because if you stayed at last time after class, we pretty much proved that the solution manual was wrong because of something that they did. And this is what they did. Essentially, they had in the... So our value for Q4 has to show up in here somewhere. If there are zeros for every single one of these values down the table, it means that it didn't show up in the equation. Q4 was multiplied by 0 every single time, which means it was never shown up. And if it never showed up, you can't find it, right? Does that make sense? Like if you can't solve for Q4 by like moving it to one side and solving for the other ones, it's not possible to do. So it has to show up here somewhere. And last class, we looked at the solution manual and it showed a 0 in every single column for the thing we were trying to find, which is not good. It means it couldn't be found. So it's wrong, I believe. All right, so this is our matrix, and like I said, I don't have the solution manual for this one, but I can tell you that this is probably right. If I don't think we've made any errors or any glaring ones. Well, I've tried. Clearly, I've tried, but we've managed to get them all. Let me see. So this is 4, 4, 9. Yep. Okay, it's 9. I was making sure we counted them off right. So this is your matrix for this question. There should be an equal sign in here, but I never drew them. But it should be like that. But anyway, so is there any questions? Because if there are not, I will go ahead and end the show. But yeah, I think for your exam, you guys will have a bit more time. Or I will give you one question that maybe has like 4 links or something. If you can do it one time, I can. If you can do a question like this once, you can do it again. The only thing stopping you is how long it will take, right? Like if the exam was 3 hours, I think you could do 2 questions fairly easily and not break a sweat. But if I tried to give you 2 questions in 1 hour and 15, I wouldn't be grading you on your quality. I'd be grading you on how fast you moved, which is not really what I'm about. So I'm about the quality. So I will probably just give you one question that has 4 links or 3 links. It'll be either 3 to 4 links. It'll be somewhere in there. I have to find a good question. Does that sound good?